The void meets relativity, space as a dynamic fabric. With the early 20th century's revolutionary theories of relativity, the concept of the cosmic void underwent a radical transformation. Albert Einstein's general theory of relativity described space not as a passive emptiness, but as a dynamic fabric capable of warping, stretching, and curving under the influence of mass and energy. The void, once considered inert, was revealed to be flexible, malleable, and intimately connected to the forces governing the universe. According to Einstein, the presence of matter and energy bends the fabric of space-time, creating the phenomenon we perceive as gravity. Planets orbit stars, galaxies cluster, and light bends, all because the emptiness of space itself is responsive. The void became a medium, not a mere container, and its properties directly influence the motions of celestial bodies. The concept of empty space expanded to include curvature, tension, and energy, linking the void to the fundamental laws of physics. Simultaneously, quantum mechanics continued to reveal the void's hidden complexity. Empty space, even when devoid of matter, teemed with fluctuations and transient particles, a dynamic quantum foam underpinning reality at the smallest scales. These quantum effects suggested that the vacuum was never truly empty. It possessed energy, unpredictability, and the capacity to influence the universe in subtle but profound ways. The interplay between relativity and quantum physics positioned the void as both the stage and an active participant in cosmic evolution. This era also marked a turning point in philosophical reflection. If the emptiness of space could bend, ripple, and vibrate under the influence of unseen forces, what did this imply about human perception? The void challenged intuitive notions of space, time, and causality, showing that what appears empty is, in fact, rich with structure and influence. Humanity began to understand that the cosmos is not merely observed from a distance. It is an immersive reality, with emptiness itself shaping experience, motion, and existence. In the practical realm, observations such as gravitational lensing confirmed these theories. Light from distant stars and galaxies bends around massive clusters, revealing the curvature of the cosmic void and the presence of dark matter within it. The invisible properties of the void, once theoretical, became observable and measurable, highlighting the precision with which the universe operates even in its seemingly empty regions. This chapter also includes a crucial interactive insight. Consider your own place in this vast expanse. As we study the void, pause and reflect. Comment your thoughts below. How does contemplating an active, dynamic emptiness change your perception of the universe? Where do you think the void ends, or does it truly have an end? Engaging with these questions connects viewers to the cosmos, merging human curiosity with scientific inquiry. The void, as revealed by relativity and quantum theory, is both emptiness and substance. It is a canvas, a medium, and a field of influence. Space bends, stretches, and responds. Light curves along its contours, and energy flows through its invisible fabric. Far from being nothing, the void is an essential actor in the universe, guiding motion, shaping structure, and inspiring reflection. Humanity's journey through this dynamic emptiness continues, inviting exploration, understanding, and awe at the subtle, invisible forces that govern all things. The quantum vacuum, unseen energy of space. Beyond the macroscopic effects described by relativity, the void reveals another astonishing reality at the quantum level. Even the emptiest regions of space are never truly empty. Quantum mechanics predicts that vacuum energy permeates every corner of the cosmos, a restless sea of fluctuating particles that appear and vanish in fractions of a second. This quantum vacuum challenges the classical notion of nothingness, presenting a universe alive with subtle activity. Zero-point energy, the irreducible minimum energy present in the vacuum, ensures that space is never silent. These fluctuations generate transient particle-antiparticle pairs, brief blips of matter and energy that flicker into existence before annihilating each other. Though imperceptible on everyday scales, collectively these quantum phenomena influence cosmic processes, seeding energy fields and shaping forces that govern galaxies, stars, and even the expansion of the universe itself. The implications of a dynamic quantum vacuum extend into cosmology. The energy contained within empty space may contribute to dark energy, the mysterious force accelerating the universe's expansion. In this sense, the void is not passive. It acts as a reservoir of potential, a subtle engine behind the largest structures in existence. The very emptiness between galaxies may drive the evolution of the cosmos, making the void both invisible and indispensable. Human understanding of the quantum vacuum also blurs the boundary between philosophy and physics. The emptiness once imagined as void of meaning now appears as a dynamic medium full of unseen interactions. Concepts such as causality, locality, and reality itself are challenged by the behavior of virtual particles and fluctuating fields. The void becomes not merely a backdrop for events but a participant in them, subtly guiding the evolution of energy and matter. Technological advances, including precise measurements of the Casimir effect and studies of vacuum fluctuations, have confirmed the existence of these invisible processes. Researchers can now observe indirect evidence of quantum activity, revealing that the vacuum is not a static emptiness but a complex energetic field. The cosmos, in all its vastness, contains not only observable matter and light but also this hidden, humming foundation that permeates space itself. As we continue our exploration of the cosmic void, it is essential to reflect on its philosophical resonance. Emptiness, far from being passive, is alive with potential and structure. The void reminds us that absence does not equate to insignificance. Within it lies the force driving galaxies apart, the energy shaping the fate of the universe, and the subtle rhythms of reality itself. The journey through the quantum vacuum naturally leads to broader questions about the nature of existence. How can something so elusive exert such profound influence? How does humanity's perception of nothingness change in the face of a universe where emptiness is dynamic and potent? As we answer these questions, we arrive at the realization that the cosmic void is both the stage and the performer, a paradoxical space that embodies the unity of emptiness and influence, virtual particles, and the fleeting nature of the void. The void of space, as explored through quantum mechanics, teems with invisible activity. At its heart lies the concept of virtual particles, ephemeral entities that blink into existence only to vanish almost instantly. These particles, though fleeting, leave measurable effects on the universe, subtly influencing forces and the behavior of matter across vast distances. Virtual particles are created in pairs, particle and antiparticle, and almost immediately annihilate each other. While imperceptible to human senses, their influence can be detected in phenomena like the Lamb shift, subtle changes in atomic energy levels, and the Casimir effect, which causes attraction between closely spaced metal plates in a vacuum. These quantum processes reveal that the void is not a passive emptiness but a dynamic stage on which fundamental forces play out. Cosmologically, virtual particles contribute to the quantum vacuum energy, which may play a role in the universe's accelerated expansion. In this sense, what appears as emptiness is actually a seething, invisible field, constantly shaping the evolution of galaxies, stars, and the very fabric of space-time. The vacuum, once imagined as inert, is revealed as an intricate network of fleeting energy fluctuations, a paradoxical combination of nothingness and influence. The philosophical implications are profound. Humanity has long equated emptiness with absence or insignificance, yet the void demonstrates that invisibility does not equal irrelevance. The fleeting dance of virtual particles exemplifies how the unseen can have enormous consequences, guiding the evolution of cosmic structures in ways only now being understood. Even in regions appearing utterly empty, nature operates with invisible precision. Technological advances such as particle accelerators and high-precision atomic measurements allow scientists to detect the fingerprints of these virtual particles. By studying the vacuum, researchers gain insight into the forces governing the universe, from the behavior of fundamental particles to the movement of galaxies. The void emerges as a bridge between quantum scales and cosmic scales, linking the smallest units of energy with the largest structures known. In contemplating the fleeting activity of the void, viewers are invited to reflect. The universe is not as empty as it seems. Comment your thoughts below. Can nothingness truly exist if it has the power to shape everything? These invisible processes remind us that emptiness is both subtle and profound, a paradoxical engine of cosmic evolution. The interplay of relativity and quantum mechanics in the void. The union of Einstein's relativity with quantum mechanics provides the most profound understanding of the void. On one hand, relativity portrays space-time as a flexible, curved fabric bending under the influence of mass and energy. On the other hand, quantum mechanics reveals an active vacuum, alive with energy fluctuations and virtual particles. Together, these perspectives depict the void as both a macroscopic stage and a microscopic furnace of activity. Gravitational waves, ripples in spacetime caused by massive cosmic events, illustrate the void's dynamic nature on a grand scale. As black holes collide or neutron stars merge, the surrounding emptiness responds, propagating disturbances across billions of light years. The void reacts, stretches, and carries energy, proving that even the emptiest regions of space are interactive and energetic. Meanwhile, at the quantum level, fluctuations continue to occur, guiding particle behavior, influencing fields, and potentially contributing to dark energy. This duality, the massive and the minute, highlights the complexity of nothingness. Space is neither void nor passive. It is a medium through which the universe operates, from the largest galactic structures to the tiniest quantum events. Philosophically, this interplay challenges human perception. Emptiness is no longer synonymous with inactivity or irrelevance. Instead, it represents a stage of interaction, a medium of connection between forces and phenomena across all scales. The void becomes a place of paradox, simultaneously vast and minute, silent and active, empty yet foundational. By studying this relationship, scientists explore the origins of the cosmos and the mechanisms guiding its expansion. Each gravitational ripple and quantum fluctuation adds to our understanding of how emptiness shapes reality. The void becomes a key player in unraveling the universe's mysteries, reminding humanity that true insight often lies in what is invisible yet omnipresent. The cosmic void as a bridge between science and philosophy. The study of the void unites scientific inquiry with philosophical reflection. Modern cosmology portrays emptiness as an active, energetic, and influential component of the universe. Quantum vacuums, dark energy, gravitational waves all illustrate that space is never inert. Yet, this scientific understanding resonates with age-old philosophical ideas about the nature of nothingness, potential, and existence. The void's hidden forces reveal that emptiness is not absence but possibility. The largest cosmic structures and the tiniest quantum effects coexist within this invisible medium, showing that the universe operates through subtle, interconnected dynamics. Humanity's perception of emptiness shifts. The void is no longer a backdrop, but an essential participant, a silent architect guiding cosmic evolution. Reflecting on the void inspires humility. The enormity of empty space dwarfs human existence, reminding us of our place within the cosmos. Yet, it also sparks wonder, imagination, and curiosity. The void is a source of inspiration, connecting scientific understanding with philosophical contemplation about life, existence, and the unknown. By embracing the dynamic, energetic, and paradoxical nature of emptiness, humanity gains both knowledge and perspective. The void teaches that influence does not require substance, that silence can guide motion, and that the unseen can shape reality. Science and philosophy converge in this realization. The cosmic void, far from nothing, is a profound and indispensable aspect of the universe. Through these chapters, Section 6 closes as a comprehensive exploration of relativity, quantum mechanics, and the philosophical implications of nothingness. The cosmic void emerges as both scientific phenomenon and existential concept, a dynamic, mysterious, and ultimately awe-inspiring part of reality. The illusion of nothingness in human perception. When we talk about nothingness, it is not only a scientific puzzle but also a deeply human one. Our minds are built to grasp things, shapes, colors, sounds, movements, but what happens when we try to imagine the absence of all things? Immediately, the brain fills in the void with an image of blackness or a silent blank canvas, as if even in trying to understand emptiness, we cannot escape projecting something into it. The cosmic void confronts us with this limitation. Astronomers describe vast regions of space nearly empty of matter, where galaxies are absent, where light itself seems swallowed into darkness. Yet even these voids are not truly empty. They hum with quantum fluctuations, with background radiation, with the faint gravitational tug of distant structures. For the human imagination, this raises a paradox. Is true nothingness even possible? Or is it simply an illusion shaped by the way our minds try to conceptualize absence? Across cultures, philosophers have long grappled with this question. Ancient Greek thinkers like Parmenides argued that nothing cannot exist because to think of it already makes it something. Centuries later, Buddhist philosophy developed an entirely different lens, suggesting that emptiness is not the absence of reality, but the interdependence of all things, a recognition that nothing exists independently. Both traditions, in their own way, mirror the modern struggle of cosmology. When scientists describe the vacuum of space, are they describing the absence of matter, or are they discovering the hidden fabric that gives rise to everything? Consider how language itself resists nothingness. We say a void, an emptiness, a silence, but these words give shape to the very thing they are meant to erase. When physicists talk about vacuum, it is not truly nothing. The vacuum of space is restless, alive with quantum energy that flickers in and out of existence. The human imagination, in trying to see nothing, always finds itself staring into something deeper. A black screen filled with meaning, a silence heavy with possibility, or a darkness that holds more mystery than clarity. This is why the idea of nothingness fascinates us. It challenges not only science but also perception itself. When we lie awake at night, staring into the dark ceiling, our mind still projects faces, memories, shapes, fears. In the same way, when we look into the cosmic abyss, we are not seeing nothing but the limitations of our own vision. What we call nothing is a mirror reflecting our need to find something. Perhaps this is why nothingness, far from being a dead concept, has become one of the most vibrant questions in physics and philosophy alike. The cosmic void, then, is not only a scientific frontier but also a psychological one. To confront it is to confront our own boundaries. The universe may contain regions stripped of stars, galaxies, and light, but in the attempt to imagine what they are, we are forced to confront the very structure of human thought. In that sense, the study of nothing is not an escape from meaning, but one of the deepest encounters with it. The void between galaxies. When we gaze into the night sky, most of what we see are luminous islands. Stars, galaxies, and nebulae burning brightly against a backdrop of black. But the truth is more unsettling. The overwhelming majority of the universe is not filled with stars, but with vast expanses of nothingness. These are the intergalactic voids, unimaginably large regions where galaxies are sparse, where silence rules, and where light takes millions of years to find another point of origin. If our universe is a cosmic web, then these voids are the empty spaces between its threads. To understand the magnitude of these voids, imagine a single galaxy like the Milky Way, with its billions of stars. Now stretch your vision beyond it into a space where galaxies become mere specks, and even those specks begin to thin out. What emerges is a landscape dominated by darkness, gigantic cavities spanning hundreds of millions of light years, where matter is nearly absent. Astronomers map these voids not by what they contain, but by what they lack. They are outlined by filaments of galaxies, like glowing threads tracing the shape of an unseen tapestry, while the interiors remain profoundly empty. The largest of these voids, such as the Bootes void, challenge our imagination. Discovered in the 1980s, this cosmic desert measures nearly 330 million light-years across. To put that in perspective, if the Milky Way were placed at its center, we would not see another major galaxy for hundreds of millions of years of travel at the speed of light. It is a silence so absolute that it borders on terrifying, a reminder of how fragile our cosmic neighborhood truly is, cradled within threads of matter surrounded by overwhelming emptiness. Yet even here, in what seems like ultimate nothingness, the void is not completely barren. Dark matter threads through it invisibly, unseen but exerting growl. Gravitational pull, stray dwarf galaxies, and clouds of intergalactic gas drift silently through the abyss. These faint presences whisper that even in emptiness, something lingers, subtle but undeniable. The universe refuses to give us absolute void. Instead, it leaves hints of structure, fragile traces reminding us that existence clings even in the loneliest spaces. For philosophers, these intergalactic deserts offer more than scientific intrigue. They symbolize isolation, reminding us that life, consciousness, and civilization are fragile sparks surrounded by an overwhelming sea of absence. To peer into a void is to confront not just the scale of the universe but the loneliness it implies. It is a mirror for our own existential fears, of insignificance, of emptiness, of being adrift in a cosmos that neither notices nor explains us. Astronomers, however, see beauty where others might see despair. They view voids as laboratories of purity, regions largely untouched by the chaos of galaxies. In these empty arenas, the subtle forces of dark energy reveal themselves more clearly, stretching space and accelerating the expansion of the cosmos. By studying voids, scientists gain clues about the fate of the universe, for in emptiness lies the truth about how everything is pulled apart. Imagine floating in such a void. No starlight, no planetary horizons, only a black canvas that swallows every direction. The silence would be unbearable, the sense of infinity overwhelming, and yet, within that silence we might also feel awe. A raw recognition of the scale of creation, a confrontation with the fact that nothingness is the dominant landscape of the universe. Stars and galaxies are the exceptions, voids are the rule. In the end, the void between galaxies teaches us humility. Our Earth, our Sun, even our galaxy, are fragile lights strung along a web surrounded by an ocean of absence. And it is in that absence that the universe's deepest mysteries are written, waiting for us to decipher. Dark energy and the expansion of emptiness. For centuries, humanity believed that the night sky, though vast, was eternal and unchanging. Then, in the 20th century, we discovered something unsettling. The universe is not static but expanding. Galaxies are rushing away from one another, carried on a tide of cosmic growth. And driving this acceleration is one of the greatest enigmas in modern science. Dark energy, an unseen force that thrives within the emptiest corners of space. At first glance, the idea seems paradoxical. How can nothingness exert influence? How can emptiness push galaxies apart? Yet this is exactly what the evidence tells us. Observations of distant supernovae in the late 1990s revealed that not only is the universe expanding, it is doing so at an accelerating pace. Something within the fabric of space itself is fueling this growth, stretching the cosmic web and making voids larger by the day. That something is what scientists now call dark energy. Unlike gravity, which pulls matter together, dark energy does the opposite. It pushes everything apart. Imagine space as a vast balloon. Gravity is the hand trying to keep the balloon compressed, while dark energy is the air inside, pushing outward, forcing it to grow. The astonishing truth is that nearly 70% of the universe is made of this invisible energy, meaning emptiness itself is the dominant feature of reality. The stars, the galaxies, even all the atoms that compose us, these account for only a fraction compared to the immensity of dark energy. Philosophically, dark energy reshapes how we think about nothingness. We often imagine emptiness as passive, as a void that merely waits. But dark energy teaches us the opposite. The vacuum of space is active, dynamic, restless. Even in apparent stillness, something is at work, reshaping the cosmos on scales beyond comprehension. The nothing of space is not a dead void. It is a living engine, an unseen current that sculpts the fate of galaxies. As we peer deeper into the universe, we see the effects of this mysterious force. Voids between galaxies grow wider, clusters drift farther apart, and the cosmic web stretches thinner. In billions of years, the night sky itself will look different. Galaxies that we now see as neighbors will vanish beyond a horizon of visibility, carried too far away for their light to ever reach us. Our universe is not only expanding, it is fragmenting into islands of isolation, each galaxy or cluster sealed within its own shrinking domain of visibility. For scientists, this is not merely a matter of curiosity, but a puzzle that strikes at the heart of physics. What is dark energy? Is it a property of space itself, a kind of cosmological constant woven into the fabric of the universe? Or is it the effect of some deeper, unknown field of energy that permeates reality? Even after decades of study, the answers remain elusive. Dark energy is less a solved riddle and more a reminder of how little we truly understand. For us, ordinary humans, dark energy is something else entirely. It is a poetic reminder that emptiness is not truly empty. The void itself is pregnant with possibility, alive with invisible currents that shape the destiny of stars and galaxies. When we look at the night sky, we see the stars shining against a backdrop of darkness. But it is the darkness that rules, stretching space and ensuring that the future of the universe will be dominated not by matter, but by expansion. In confronting dark energy, we realize that the true power of the cosmos lies not in its brilliant lights, but in its unseen shadows. The void, it seems, is the universe's greatest architect, forever stretching the boundaries of existence. The event horizon of nothingness. There are places in the universe where nothingness itself takes on a terrifying form. These are the realms surrounding black holes, the most extreme objects in existence. At their heart, black holes are places where gravity has triumphed completely, crushing matter into a point of infinite density. Yet for us, the most haunting feature of a black hole is not its core but the invisible boundary that surrounds it, the event horizon. This is the edge of no return, the threshold beyond which even light cannot escape. The event horizon is, in a sense, the purest embodiment of cosmic nothingness. It is not a physical surface but a boundary drawn by the laws of physics themselves. On one side lies the familiar universe, where light, time, and matter still obey the rules we know. On the other side lies a realm forever sealed off, inaccessible to observation, hidden in perpetual shadow. To an outside observer, the event horizon appears as a perfect void, featureless, silent, unyielding. And yet, paradoxically, the event horizon is not entirely empty. According to quantum mechanics, even in the vacuum of space, fleeting particles constantly pop in and out of existence. Near the event horizon, this quantum foam behaves strangely. Some particles are swallowed by the black hole, while others escape, giving rise to what physicist Stephen Hawking famously described as Hawking radiation. In this way, black holes slowly leak energy, turning what seems like an eternal void into something fragile, destined to evaporate over incomprehensible spans of time. To stand at the edge of an event horizon, if such a thing were possible, would be to stand before the ultimate boundary of knowledge. Time itself stretches and warps near this threshold. From far away, a falling object appears to slow, its light red-shifting until it fades into nothingness. To the objective gate itself, however, the crossing is swift and final, an unstoppable plunge into the abyss. Here, the difference between something and nothing dissolves into mystery, for the horizon is not truly a place, but a limit to what can ever be seen or known. Philosophers might describe the event horizon as the most literal manifestation of the unknown. It embodies the limits of perception, the wall beyond which our questions cannot yet reach. For centuries, humanity has sought to understand the infinite, to grasp the edges of reality. The event horizon reminds us that some boundaries are not merely distant, they may be absolute. What lies beyond remains hidden, perhaps forever. Yet the existence of event horizons has already reshaped our understanding of the cosmos. They show us that emptiness is not passive but dynamic, sculpted by gravity and time. They reveal that nothingness is not absence, but transformation, a threshold where matter becomes information, and information itself may dissolve. In their silent darkness, black holes teach us humility. They whisper that even in a universe of endless discovery, there will always remain mysteries deeper than imagination. To call the event horizon nothingness is both accurate and misleading. It is nothing in the sense that nothing escapes from it, but it is also something, the ultimate frontier, a border that shapes galaxies and powers the engines of creation. For supermassive black holes, these voids anchor entire galaxies, holding billions of stars in their orbit. In this way, emptiness is revealed not as a hollow absence but as a foundation on which the very structure of the cosmos rests. In the end, the event horizon is a paradox, a place where nothing defines everything. It is a cosmic silence so absolute that it reshapes the destiny of stars. To look upon it is to see the face of the void itself, timeless, infinite, and beyond. In comprehension, the human search for meaning in the void. For centuries, human beings have gazed into the night sky and wondered whether the universe is empty or alive with hidden truths. Our ancestors told stories of gods, monsters, and spirits filling the darkness above. Later, philosophers pondered whether the void was truly nothing or whether it concealed some deeper order. Today, scientists use satellites and telescopes to peer farther into space than ever before. Yet the question remains, what does it mean that the universe is filled mostly with emptiness? When astronomers measure the contents of the cosmos, they find a staggering truth. All the stars, planets, and galaxies, the things we see and touch, make up less than 5% of everything. The rest is invisible. Roughly a quarter is dark matter, an unknown substance that holds galaxies together. And nearly 70% is dark energy, a force driving the expansion of space itself. In other words, the universe is not simply empty, it is filled with mysteries more vast than the stars themselves. The void is not a blank canvas, but an active participant in shaping cosmic history. Yet beyond scientific measurements, the idea of nothingness carries a weight that is deeply human. For many, the thought of an infinite void is unsettling, even terrifying. If space stretches endlessly, if galaxies drift farther apart forever, what does that say about our place in the story of existence? Are we fleeting sparks in a dark, indifferent ocean? Or is the void itself a kind of stage, necessary for meaning to emerge? The tension between awe and fear is what makes the study of nothingness so profound. It is not just physics, it is philosophy. Some thinkers argue that the void gives value to everything that exists. Without emptiness, there would be no room for stars to burn, no space for galaxies to expand, no cradle for life to rise. The silence of the cosmos highlights the rarity of life's song. In this way, nothingness is not an enemy but a companion. It frames our stories, shaping how we define significance. Even religions have grappled with the void, sometimes as chaos to be overcome, sometimes as a sacred mystery beyond comprehension. In every era, the empty sky has been a mirror reflecting humanity's deepest fears and highest hopes. The modern age has not ended this search. Instead, it has intensified it. With each new telescope launched into orbit, with each black hole mapped, we are forced to reimagine our place in a universe dominated by emptiness. Technology may allow us to measure the echo of the Big Bang or detect ripples in space-time, but these achievements only raise further questions. If nothingness itself can ripple, can glow, can pull galaxies apart, then perhaps it is not truly nothing at all. Perhaps the void is alive in ways we cannot yet fathom. And so, as we stand at this moment in history, humanity's journey through the cosmic void is not only about physics, but about identity. To study nothingness is to confront the fragility of our existence and the grandeur of our imagination. It challenges us to ask not only what the universe is made of, but why there is something rather than nothing at all. These questions have no easy answers, yet the act of asking them transforms the void into something rich with meaning. The cosmic void remains vast, silent, and mysterious, but within that silence, humanity finds its voice. We tell stories, build theories, and dream of futures where the emptiness becomes a canvas for exploration. Nothingness, it seems, is never truly empty. It is the stage upon which we discover ourselves, the silent architects of the void. When we speak of nothingness in the cosmic sense, it often conjures the image of vast, empty space, an endless black expanse dotted with the occasional star or galaxy. Yet to astrophysicists, this emptiness is far from truly empty. Instead, it is structured, influenced and shaped by silent architects that work invisibly across the universe: gravity, dark energy, and quantum fluctuations. These forces weave the framework of what we call the void, ensuring that even in the places where there seems to be nothing, there exists an underlying order that governs the behavior of the cosmos. Gravity is the first and most familiar of these invisible architects. It pulls matter into clusters, forming galaxies and stars, while simultaneously leaving behind regions of apparent emptiness, cosmic voids where matter is scarce. Without gravity, space would lack the intricate web-like structure observed by astronomers, where vast filaments of galaxies stretch across unimaginable distances, surrounding enormous pockets of near emptiness. These voids are not accidents, they are a natural consequence of gravity's relentless pull on matter, shaping cosmic architecture across billions of years. But gravity is not the only player in this silent symphony. Enter dark energy, a mysterious force that accounts for nearly 70% of the universe's total energy. Unlike gravity, which pulls matter together, dark energy pushes space apart. Its influence is subtle yet profound, accelerating the universe's expansion and amplifying the scale of cosmic emptiness. As galaxies drift farther from one another, the voids between them grow larger and more profound. This means that nothingness itself is expanding, stretching wider with every passing moment. Dark energy ensures that the very concept of nothingness is dynamic, constantly evolving and reshaping the cosmos we inhabit. Then, on an even smaller scale, quantum mechanics introduces another layer of intrigue. According to quantum theory, even in a perfect vacuum, energy fluctuations never truly cease. Tiny bursts of energy blink into existence for fractions of a second before disappearing again, like whispers of creation within the silence of the void. These fleeting events, called quantum fluctuations, may seem insignificant, but they are believed to have seeded the earliest structures of the universe during the Big Bang. In other words, the grand cosmic web we see today may have originated from the restless murmurings of nothing. Together, these invisible architects remind us that nothingness is never static. It is constantly sculpted by forces both immense and minuscule, forces that transcend human perception yet govern the fate of galaxies, stars, and the fabric of space itself. The void becomes less of an empty absence and more of a stage where unseen forces perform their quiet, eternal dance. For astronomers, studying these forces often means mapping the voids themselves, not as blank spaces, but as dynamic regions filled with invisible influence. By measuring how galaxies move around these vast empty pockets, scientists can infer the fingerprints of dark energy and better understand the distribution of matter in the universe. These observations serve as reminders that even when we stare into apparent nothingness, we are in fact observing the subtle work of forces too vast, too strange, and too constant to be ignored. Thus, the cosmic void is not merely the absence of matter, but the product of the universe's silent architects: gravity binding, dark energy expanding, and quantum fluctuations whispering at the foundations of reality. Nothingness, it turns out, is a living canvas, endlessly shaped by forces unseen but ever present, ensuring that the void is never truly empty. The expansion of nothing. If there is one idea that redefines our understanding of emptiness in the universe, it is the notion that nothingness itself is expanding. At first, this sounds paradoxical. How can emptiness grow if it contains nothing? Yet this concept lies at the very heart of modern cosmology, reshaping how scientists interpret the fabric of the cosmos. The key to this mystery is found in the early 20th century when astronomer Edwin Hubble made a groundbreaking observation. Galaxies were not stationary. Instead, nearly all of them were moving away from one another. Their light stretched into longer wavelengths, a phenomenon known as redshift. What Hubble revealed was extraordinary. The universe was expanding, and with this expansion, the voids between galaxies were not static gaps. They were stretching, ballooning outward with time. This discovery forced a radical rethinking of cosmic emptiness. Space itself was not simply a passive backdrop where matter floated. It was an active participant, capable of stretching, bending, and evolving. The nothingness between galaxies, once assumed to be fixed, was instead dynamic, growing larger with every second. The expansion of nothing also led scientists to confront one of the most perplexing forces in physics: dark energy. Unlike ordinary energy that we can see or measure directly, dark energy is invisible, and its effects are only observable through its influence on space. Rather than allowing the expansion of the universe to slow down under the pull of gravity, dark energy accelerates it. In other words, not only is the void expanding, but the rate of this expansion is speeding up. Imagine two galaxies drifting apart in the early universe. Over billions of years, not only does the distance between them increase, but the very fabric of space between them stretches faster and faster. This acceleration means that galaxies once within reach of our telescopes will eventually slip away, their light stretched so thin that it will vanish from view forever. What remains in their place is not a tangible object, but more void, an ever-expanding sea of emptiness. This perspective transforms our understanding of the future. If the universe continues to accelerate under the influence of dark energy, the cosmic void will dominate the landscape of tomorrow. Galaxies will recede beyond the horizon of observability, leaving behind a lonely universe where only local clusters remain visible. The vast structures we marvel at today may become invisible to observers billions of years from now, their existence swallowed by the ever-growing nothingness. And yet, this expansion raises an even deeper question. What is nothingness expanding into? It is tempting to imagine the universe as a balloon inflating into a larger space, but according to current cosmology, space is not expanding into anything. It is simply creating more of itself. The void does not grow because there is an external emptiness to fill, but because space itself is dynamic, capable of generating new emptiness without limit. This idea defies common intuition, but it emphasizes the most profound aspect of cosmic nothingness. It is not passive absence, but active creation. The very structure of space is alive with the influence of dark energy, weaving a future where emptiness becomes the dominant feature of existence. Thus, when we speak of the expansion of nothing, we are not describing a silent backdrop, but the evolving heartbeat of the universe itself. What appears to be emptiness is, in fact, the most dynamic and expansive phenomenon of all, a reminder that even nothingness can grow, and in doing so, reshape the destiny of everything. The illusion of true emptiness. When most people hear the word nothing, they imagine a perfect vacuum, a place where no air, no dust, and no matter of any kind exists. It feels like the ultimate emptiness, a space so barren it contains absolutely nothing. But modern physics has revealed something startling. Such absolute nothingness does not exist. Even the deepest regions of cosmic void are not truly empty. Instead, they are filled with subtle, unseen activity, an eternal dance of energy that never ceases. This realization emerges from quantum mechanics, the branch of physics that studies the smallest scales of reality. According to this framework, the universe cannot tolerate absolute stillness. Even in the absence of particles, space is alive with what scientists call quantum fluctuations. These are tiny bursts of energy that appear and vanish in fractions of a second, giving rise to what is known as the quantum vacuum. In this sense, what appears to us as nothing is actually a restless ocean of possibilities, a seething background from which matter itself can emerge. Physicists sometimes describe the vacuum as a stage where particles continuously pop in and out of existence. These fleeting particles are called virtual particles, and while they exist for too short a time to be directly observed, their effects can be measured. For example, they contribute to forces like the Casimir effect, where two metal plates placed very close together in a vacuum feel a mysterious attraction caused by the pressure of quantum fluctuations. This is a clear demonstration that empty space is not empty at all, it is buzzing with hidden energy. This concept carries profound implications. If even nothingness is filled with activity, then the boundary between something and nothing becomes blurred. The vast cosmic void, which looks silent and dead to the human eye, is in fact pulsed, ignorant with potential. The very existence of the universe may owe itself to these quantum fluctuations, as many cosmological theories suggest that our cosmos could have emerged from a fluctuation in the vacuum itself. From nothing, a universe was born. Yet this understanding challenges the way we think about emptiness in everyday terms. We tend to think of nothing as a total absence, a blank canvas. But physics insists that even when matter and light are removed, space is never completely blank. Instead, it is structured, energetic, and unpredictable. True emptiness, in the strictest sense, may not exist anywhere at all. This leads to an almost philosophical puzzle. If there is no such thing as pure nothingness, then what exactly are we exploring when we talk about the cosmic void? Perhaps it is not nothing that dominates space, but a hidden something, an invisible foundation upon which reality is built. The cosmic void may be less like an empty desert and more like an unseen ocean, calm on the surface but endlessly turbulent below. This idea also ties directly into the mystery of dark energy. Some physicists suggest that the energy driving the expansion of the universe may be linked to the energy of the quantum vacuum itself. If so, the invisible activity of nothingness is not only real but also responsible for shaping the entire fate of the cosmos. The illusion of emptiness then becomes one of the great paradoxes of science. What appears to be nothing may be the most fundamental something of all. When we gaze into the void, we are not staring into absence but into the restless background of existence itself, a place where reality and potentiality blur together, the void as a cosmic laboratory. When we imagine the cosmic void, we often think of it as a place of absence, silent, lonely, and still. Yet scientists have come to realize that the void may actually be one of the most important laboratories the universe has to offer. Far from being irrelevant, these seemingly empty regions provide the perfect setting to test the very limits of physics and probe questions that cannot be answered within the crowded, energetic environments of galaxies and stars. One of the most fascinating qualities of cosmic voids is their isolation. In galaxies, countless gravitational influences overlap: stars, planets, dust, and black holes all tugging against one another. But in the vast expanses of intergalactic nothingness, such interference is minimal. This allows physicists to study large-scale cosmic effects more clearly. For instance, the accelerated expansion of the universe attributed to dark energy can be observed most directly in void regions. The way galaxies on the edges of voids drift away from each other provides critical data that scientists use to refine their models of cosmology. Voids also give us an unparalleled opportunity to test Einstein's theory of general relativity. Since gravity behaves differently in low-density environments, observing how matter spreads out in these empty regions can either confirm or challenge our deepest theories about how the universe works. If deviations are ever discovered, they could hint at physics beyond relativity, perhaps even toward a new theory of gravity that explains the mysteries of dark matter and dark energy. Another reason voids are so important is that they act like natural amplifiers of subtle effects. Imagine trying to hear a whisper in a crowded room. It would be nearly impossible, but in an empty hall, that same whisper would stand out clearly. Similarly, cosmic voids amplify faint high signals that would otherwise be lost amid the noise of galaxies. For example, certain types of radiation or fluctuations in the cosmic microwave background become easier to detect against the backdrop of emptiness, giving scientists cleaner data to work with. Even more intriguingly, voids may provide clues about the earliest moments of the universe. Some models suggest that the distribution of voids across space carries imprints from the Big Bang itself. By mapping the shapes, sizes, and boundaries of these cosmic gaps, researchers can reconstruct conditions from billions of years ago. In this sense, voids are like fossils, vast, silent records of the universe's earliest history. Yet the void's role as a laboratory extends beyond physics into philosophy. They invite us to ask questions about the very meaning of existence. If the majority of the cosmos is made up of emptiness, then what does that say about our place within it? Are galaxies like ours exceptions in a universe dominated not by presence, but by absence? The void seems to remind us that reality is structured less by the things we see and more by the vast unseen spaces between them. This perspective shifts our understanding of importance. We may naturally focus on stars, planets, and galaxies as the main actors of the cosmic story, but the stage itself, the emptiness in which they exist, might be the most influential character of all. Without voids, the universe could not expand as it does. Without voids, subtle cosmic patterns might remain forever hidden, and without voids, we might never question the boundary between nothing and something. Thus, the void is not a meaningless backdrop but a stage for cosmic truth. Every measurement made in these silent expanses brings us closer to unlocking the universe's deepest secrets. Human perception of the infinite. For most of human history, the night sky has served as a mirror for our imagination. Where some saw patterns of gods and heroes, others saw navigational maps guiding ships across oceans. Yet when we shift our focus from the stars themselves to the dark canvas behind them, we encounter a different kind of mystery. The void is not adorned with myths or constellations. It is vast, unbroken, and seemingly endless. How humans interpret this absence tells us as much about our psychology as it does about the cosmos. At a basic level, the concept of nothingness unsettles us. Our minds are wired to seek patterns, to fill gaps, to make sense of chaos. When confronted with the infinite emptiness of space, this instinct collides with an environment that offers no foothold. Unlike mountains, rivers, or even stars, the void gives us nothing to grasp. Philosophers argue that this is why nothingness has always carried both fear and fascination. It is not just a physical reality, it is a challenge to our way of thinking. Different cultures have responded to this challenge in unique ways. Ancient Indian philosophy developed the concept of shunyata, or emptiness, as a profound truth that everything exists in relation to what is absent. In contrast, Western traditions often treated nothingness as a void to be feared, a space where chaos or death resided. Modern science has blended these perspectives, showing that the void is not a terrifying abyss, but a natural and essential part of existence. Our interpretations are shaped not by what the void is, but by how we choose to define it. On a psychological level, the vastness of the void provokes feelings of awe. Studies in neuroscience reveal that when humans confront ideas of infinity or ungraspable scale, the brain responds with both fear and wonder. This dual reaction explains why images of deep space can simultaneously calm and unsettle us. The void reminds us of our smallness, yet it also expands our imagination, offering a canvas where the limits of possibility seem to dissolve. Artists and writers have long drawn on this tension. From science fiction novels to surrealist paintings, the theme of cosmic emptiness is used to explore identity, purpose, and mortality. The void becomes a metaphor for the unknown parts of ourselves, the unanswered questions of life, and the mysteries of death. In this way, our confrontation with nothingness is deeply personal. Each gaze into the dark sky is also a reflection inward, forcing us to ask, what does it mean to exist against a backdrop of infinity? Technological progress has only intensified this dialogue. Telescopes that peer into billions of light years of darkness show us not only galaxies, but also the staggering scales of emptiness between them. Every discovery of a new cosmic void reinforces the humbling truth. The universe is far emptier than it is full. Yet rather than diminish us, this knowledge can inspire a sense of connection. Just as we live within Earth's ecosystems, we also live within the structure of the cosmic void. Its presence shapes everything, from the movement of galaxies to the meaning we assign to existence. Ultimately, the human perception of infinite nothingness blends science with spirituality. We may never fully comprehend the void, but our attempts to describe it bring us closer to understanding both the universe and ourselves. The dark stretches of space are not just places where matter is absent, they are vast mirrors in which we glimpse the limits of human thought. The mathematics of the void, numbers, are the language through which humanity attempts to describe the indescribable. When we face the enormity of the cosmos and the strangeness of nothingness, mathematics becomes our most powerful tool. Unlike myths or metaphors, numbers allow us to measure, to predict, and to frame the unseeable void in terms that human minds can process. But what does it mean to mathematically define emptiness? Can equations truly capture something that by definition has no substance? One of the earliest mathematical encounters with nothingness was the invention of zero. Civilizations like the Babylonians and Mayans used symbols to denote absence, but it was in ancient India that zero became a full-fledged number with its own properties. This was revolutionary. Suddenly, emptiness was not just a lack but a value in its own right. From this moment, the void entered human mathematics, allowing the development of algebra, calculus, and the frameworks we now use to describe the fabric of the universe. Without zero, we could not calculate infinity, nor could we express the limits of equations that model cosmic space. Modern cosmology takes this foundation further by applying mathematics to the very structure of the void. Einstein's field equations of general relativity, for instance, describe how space-time curves in the presence of mass and energy. But what about regions where mass and energy are nearly absent? The math reveals something startling. Emptiness is not truly empty. Even in the most barren regions of the universe, space-time has a geometry that shapes how light and matter move. The void bends, stretches, and expands, an active participant in the cosmic drama. Physicists also use probability and quantum mechanics to probe the void. The Heisenberg uncertainty principle implies that even at absolute zero energy, fluctuations must exist. Mathematically, this means the vacuum is filled with probabilities, constantly shifting and interacting. When scientists model these fluctuations, the numbers predict astonishing effects, like the Casimir force, a measurable attraction between plates placed in a vacuum arising purely from the quantum void. Through equations, what once seemed like perfect nothingness reveals itself as a restless sea of invisible activity. Infinity adds another layer of complexity. When cosmologists attempt to model the size of the universe, equations often lead to infinite results. Is the void truly endless, or are we misapplying our mathematics? Infinity is both a useful concept and a philosophical paradox. It allows us to stretch equations to their logical extreme, but it also raises the question: can human mathematics, rooted in finite experience, ever fully encompass the infinite void? Some argue that mathematics does not merely describe the universe, it shapes our understanding of what is possible. In this sense, the way we define the void mathematically may alter how we perceive its nature. The beauty of this approach lies in its precision. Through equations, scientists can predict how galaxies drift apart in an expanding void, how light bends near empty stretches of curved space-time, and even how the void might one day influence the ultimate fate of the cosmos. These predictions are not guesses, but measurable consequences of mathematics. The numbers become a bridge between human imagination and the vast silence of intergalactic space. In the end, the mathematics of the void teaches us something profound. Emptiness can be described, modeled, and predicted, but it resists being reduced to mere nothing. Equations reveal the hidden structure of absence, showing that the void is both mathematically elegant and endlessly mysterious. Numbers, in this sense, are not just human inventions. They are windows into the truth of the infinite dark. Quantum fields and the illusion of emptiness. At first glance, the void between stars seems like a silent desert, cold, dark, and utterly devoid of substance. But when physics shifts from the macroscopic to the microscopic, this emptiness dissolves into something far stranger. The realm of quantum mechanics paints a picture where nothingness is not absence but activity, a theater of constant fluctuation. To understand the quantum void is to uncover the illusion of emptiness itself. According to quantum field theory, what we call empty space is filled with invisible fields that extend throughout the universe. These fields are the foundation from which particles and forces emerge. Every electron, every photon, every quark arises as an excitation, a vibration of these underlying fields. In other words, the empty vacuum is not a blank slate but a sea of potential, an invisible stage where reality itself is constructed. One of the most astonishing consequences of this is the phenomenon of virtual particles. In the quantum vacuum, pairs of particles and antiparticles spontaneously appear, exist for a fleeting instant, and then annihilate each other. Though ephemeral, their effects are measurable. The Casimir effect, for example, demonstrates that two uncharged plates in a vacuum experience a tiny force pushing them together. This is not magic, but the result of quantum fluctuations, the restless heartbeat of the void. What looks like nothing is, in fact, a vibrant dance of creation and destruction. This constant flickering challenges our intuition. To human senses, emptiness feels static, a background. But quantum mechanics insists that stillness is impossible. Even the lowest energy state, the so-called vacuum state, holds fluctuations. These vacuum fluctuations may even be responsible for one of the greatest mysteries of the cosmos, dark energy. If space itself is phi, held with quantum energy, this could explain why the universe's expansion is accelerating. The void, rather than being passive, might be the very engine driving cosmic evolution. The quantum perspective also blurs the line between matter and emptiness. Particles emerge not from some external source but from the vacuum itself. This leads to philosophical questions. Is emptiness truly empty if it contains the potential for everything? If matter and energy are temporary ripples, does the void become the fundamental reality with particles as its fleeting expressions? The more physicists probe, the less the word nothing seems to apply. Experiments with particle accelerators provide further hints. High-energy collisions can momentarily create conditions resembling the early universe where fields dominated and particles emerged from the void. In these experiments, scientists glimpse how the vacuum is not merely background but active participant. The void holds memory, structure, and possibility, defying its apparent silence. Even time itself is affected by these fluctuations. According to quantum theory, time is not a smooth river, but a jittery, uncertain flow at the smallest scales. This quantum form means that emptiness is textured, bubbling, and ever-changing. The void, paradoxically, is alive with uncertainty. For the everyday observer gazing at the night sky, the distance between stars might appear tranquil, a pause in the cosmos. But quantum physics reveals that beneath this calm lies ceaseless activity. It is a reminder that our senses capture only the surface of reality. The true nature of emptiness is dynamic, restless, and deeply creative. Thus, the void is no illusion to be dismissed. It is the foundation of everything. What we call nothing is, in truth, the origin of all things, a stage of infinite potential where reality itself arises. Quantum mechanics teaches us that the silence of space is not absence but a hidden symphony endlessly playing beneath the surface of existence. The role of dark energy in shaping the void, the expansion of the universe, has long been one of its most defining features. From the earliest observations of Edwin Hubble, astronomers recognized that galaxies are not static but rushing away from one another, carried by the stretching of space itself. Yet what began as a gradual drift has become an accelerating race, driven by a mysterious force known as dark energy. Understanding this force is essential to understanding the very void that dominates most of the cosmos. For while dark matter helps bind galaxies together, dark energy pushes everything apart, sculpting the vast emptiness that stretches between the stars. Dark energy, unlike ordinary matter or even dark matter, does not clump or cluster. Instead, it is spread uniformly throughout space, acting as a kind of negative pressure that counteracts gravity. Its presence ensures that once galaxies move apart, they do so faster and faster, with no sign of slowing down. This acceleration, discovered in the late 1990s through the study of distant supernovae, transformed our understanding of the universe. It revealed that emptiness is not passive but dynamic, a force in its own right, shaping the largest structures we see. The influence of dark energy becomes most apparent in the cosmic voids, the immense regions of near-nothingness that make up most of the universe. In these areas, where galaxies are sparse and matter is scarce, dark energy dominates completely. With little gravity to counter its effects, the voids expand faster than regions filled with clusters and filaments. Over billions of years, this has caused the empty spaces to grow larger and emptier still, pushing galaxies into thin walls and strands that outline the web of the universe. In this way, dark energy amplifies contrast, making the voids vaster and the structures sharper. To imagine the scale of this process, picture a cosmic balloon. The galaxies are like tiny beads on its surface, while dark energy is the air inside, pushing outward. As the balloon inflates, the beads move apart. But in our universe, the balloon does not simply expand steadily, it accelerates, meaning that the further away a galaxy is, the faster it recedes. This is why distant galaxies eventually become unreachable, their light forever stretched into invisibility. For future civilizations, much of the universe we see today will fade from view, swallowed by the growing void created by dark energy's dominance. The role of dark energy also raises profound philosophical questions. If most of the universe's fate is dictated not by matter or stars, but by this unseen force woven into the very fabric of space, then our picture of reality is incomplete. What exactly is dark energy? Is it a property of space itself, described by Einstein's cosmological constant, or is it evidence of something deeper, like a new field or hidden physics? Until we find an answer, we are left with the unsettling knowledge that the very emptiness of the cosmos is more powerful than all its galaxies combined. Perhaps most intriguingly, dark energy ensures that the future will be dominated by emptiness. Galaxies will grow more isolated, stars will fade, and the cosmic web will thin. The structures that emerged so carefully from the void will eventually dissolve back into it, leaving a universe nearly empty once more. In this sense, dark energy is not only shaping the present, but also writing the ending of cosmic history, a story where nothingness is the ultimate victor, quantum fluctuations, and the birth of something from nothing. At first glance, the concept of nothing seems absolute, an empty void, free of matter, energy, and even the faintest trace of structure. Yet physics suggests that such a pure nothingness does not truly exist. At the smallest scales of reality, the quantum level, the void is restless. Empty space is never truly empty. It seethes with invisible activity. This activity takes the form of quantum fluctuations, spontaneous bursts of energy that flicker into and out of existence, sometimes producing particles that vanish just as quickly as they appeared. These fleeting phenomena may hold the key to one of the greatest mysteries, how the universe itself could have emerged from nothing. Quantum fluctuations are a direct consequence of uncertainty, a principle at the heart of quantum mechanics. According to Heisenberg's uncertainty principle, one cannot precisely determine both the energy and the duration of an event. This loophole allows the vacuum to momentarily borrow energy from nothing, creating pairs of particles and antiparticles before annihilating them again. Though ephemeral, these events leave measurable imprints, shaping the fabric of space-time in subtle but profound ways. One of the most dramatic examples of this process occurs near the edges of black holes, where so-called virtual particles can become real. When particle pairs form near the event horizon, one particle may fall into the black hole while the other escapes. This process, known as Hawking radiation, gradually saps black holes of their mass. It is a striking reminder that even the darkest and most seemingly empty corners of the universe are animated by quantum fluctuations. Nothingness, in this sense, is not a static void, but a dynamic stage where energy continuously dances into and out of reality. Beyond black holes' quantum fluctuations may also explain the very birth of the cosmos. Cosmologists propose that the universe itself could have sprung from a quantum fluctuation in a primordial void. In this view, the Big Bang was not the emergence of matter from absolute nothingness, but rather a transition, where a fluctuation inflated into the vast structured universe we see today. The idea is difficult to comprehend, yet it offers a bridge between the concept of nothing and the existence of everything. If correct, it suggests that the cosmos itself is proof that nothingness is never truly empty. The influence of quantum fluctuations is also recorded in the cosmic microwave background, the faint afterglow of the Big Bang. Tiny variations in temperature across this radiation are thought to be the fingerprints of fluctuations that occurred in the earliest moments of the universe. Over billions of years, these minute differences seeded the formation of galaxies and clusters. In other words, the vast cosmic structures we observe today may all trace their origins back to the restless energy of nothing. Philosophically, this challenges our everyday notions of emptiness. For most of us, nothing means absence, but in physics, absence is itself pregnant with potential. The vacuum is not an inert backdrop, but a field of possibilities. Quantum fluctuations reveal that even in the absence of matter, the seeds of creation exist. This forces us to ask deeper questions. Is nothingness truly possible, or is it merely an illusion born of our limited perception? The study of quantum fluctuations demonstrates that the void is not the end but the beginning. From it, particles emerge, forces interact, and entire universes may be born. What appears as emptiness may be the most fertile state imaginable, a hidden reservoir where the boundaries between nothing and everything blur. In this paradox lies one of the greatest lessons of modern science, that creation may not require a cause, only the restless potential of nothing itself. Philosophical implications of a restless void. The scientific discoveries about quantum fluctuations, virtual particles, and the seething energy of the vacuum lead to an unsettling realization. Nothingness may not exist in the way humans have imagined for centuries. Instead of an absolute emptiness, the universe appears to be built upon a foundation of restless potential, where something is always stirring beneath the surface. This revelation not only challenges physics but also forces us to rethink philosophy, metaphysics, and even spirituality. For ancient philosophers, nothingness was often treated as an abstract concept, a canvas upon which existence is painted. Aristotle argued that nature abhors a vacuum, suggesting that pure emptiness was impossible. Later thinkers wrestled with the paradox of imagining a state where there is literally nothing, no space, no time, no matter. Modern physics, with its discoveries of quantum fluctuations, aligns strangely with these ancient doubts, confirming that what appears to be a void is actually far from empty. This perspective reshapes the age-old question of creation. How does something come from nothing? If the void itself is never truly empty, but rather a bubbling sea of possibility, then creation may not be a violation of natural law, but an inevitable unfolding. Instead of asking why the universe exists, one might ask whether it could ever have not existed. If fluctuations are unavoidable, then perhaps existence was destined to emerge sooner or later from the fertile ground of the vacuum. Such ideas resonate deeply with spiritual traditions. Many mystical philosophies describe creation as arising from an infinite, unseen potential, the Tao, Brahman, or the void in Buddhist thought. While science and religion operate in different domains, the parallels are striking. Both point toward a reality where nothingness is a lifeless absence but a hidden fullness, an origin point brimming with possibility. For some, the quantum vacuum is a scientific confirmation of these ancient intuitions. For others, it raises new questions. Is the universe truly self-sustaining, or is there a deeper mystery still beyond our reach? The implications stretch even further. If nothingness itself is unstable and creative, then the universe may not be unique. Cosmologists have proposed the idea of a multiverse, where countless universes continually arise out of the vacuum, each with its own laws of physics. Our cosmos could be one of many, a single spark in an infinite sea of creation. If true, the vastness of reality is far beyond anything humans can easily comprehend. What we call the universe might be only one chapter in a book without end, written by the restless hand of the void. Philosophically, this challenges the human desire for final answers. For centuries, we sought to identify an ultimate beginning, a first cause, a divine spark, or a singular moment when nothing became something. But if the vacuum is eternally active, then beginnings are not singular but continuous. There may never have been a moment of absolute nothingness, only cycles of emergence and dissolution. This vision of reality is less comforting than a clear origin story, yet it is profoundly humbling. It situates humanity in a cosmos where creation is ongoing and infinite rather than fixed and finite. Ultimately, the study of nothingness may reveal more about ourselves than about the void itself. Humans seek meaning, narrative, and closure, but the universe resists such simplicity. Nothingness is not the blank page we imagine. It is a symphony of invisible activity, a stage where potential forever stirs into being. To grapple with this truth is to confront the limits of our knowledge and the wonder of existence itself in tides. A restless void, we glimpse both the fragility of our place in the cosmos and the grandeur of the mystery that surrounds us. The human quest for meaning in the void. Across centuries, humanity has gazed into the sky with a single burning question: what does it all mean? We have charted stars, measured galaxies, and built instruments that can peer into the faintest whispers of radiation left over from the dawn of the universe. Yet the more we uncover, the deeper the abyss seems to grow. In this chapter, we stand at the threshold of science and philosophy, attempting to interpret what the cosmic void reveals not only about the nature of space, but about ourselves. The void is often imagined as the absence of everything, an emptiness so vast that even light surrenders to its reach. But within this nothingness, we encounter paradox. For the void is not truly nothing. It is space infused with quantum fluctuations, the restless dance of virtual particles appearing and vanishing beyond our perception. To modern science, the void is a canvas of potential, humming with energy. To philosophy, it becomes a mirror for the human condition. How can meaning emerge in an expanse that seems to strip away all certainty? Ancient thinkers wrestled with similar questions long before telescopes ever scanned the heavens. The Greek philosopher Democritus spoke of the void as the essential stage upon which atoms move, while Indian traditions of Vedanta described cosmic emptiness as both an illusion and the ultimate truth. Centuries later, existentialists such as Sartre and Camus returned to the concept of void, not in the sky but within the soul, challenging humanity to craft purpose against a backdrop of cosmic indifference. Today, astrophysics and philosophy converge on an eerie realization. The universe is expanding into greater and greater emptiness. Galaxies drift farther apart, their light stretched thinner until one distant future, only our own local group of stars may remain visible. If existence be maze shrouded in such darkness, where does that leave the narrative of humankind? For some, it suggests despair, an ultimate isolation that renders us insignificant. For others, it ignites awe, that in this brief cosmic window, consciousness arose to witness the universe at all. In this way, the void sharpens our sense of urgency. Life on Earth is fleeting compared to the timescales of stars. Yet within our short span, we have managed to probe the structure of galaxies, simulate the birth of the cosmos, and compose stories that stretch across millennia. The void may suggest indifference, but our ability to ask these questions, to turn emptiness into inquiry, is uniquely human. Far from diminishing our worth, it may be what defines it. Standing at this crossroads, the void becomes more than a scientific puzzle. It becomes a stage for human meaning. We are the storytellers of the universe, weaving threads of science and myth to make sense of the abyss. Whether one sees the void as hostile or sacred, indifferent or alive with hidden potential, it reflects back the narratives we create. To peer into the cosmic void is, ultimately, to peer into ourselves. Fragile, curious, and determined to find light in the darkness. Science meets philosophy in the face of nothingness. When we explore the cosmic void, we often treat it as the ultimate frontier of physics, a landscape to be measured, quantified, and explained. Yet the very idea of nothingness refuses to stay locked inside equations. It slips into the realm of philosophy, demanding that we ask not only what the universe is, but why it exists at all. Science provides us with astonishing tools, but when confronted with the vast emptiness between galaxies, even science pauses, leaving a space where human thought and meaning must enter. Cosmologists describe the vacuum of space as quantum foam, an invisible stage buzzing with fluctuations that could give rise to particles, energy, or perhaps even new universes. These ideas stretch our imaginations, but they also expose the limits of human language. How do we describe a place where time and matter seem to dissolve? The ancient paradox resurfaces. How can nothing still hold the potential to become something? It is a question as old as philosophy itself, now reframed in the glow of telescopes and particle accelerators. For philosophers, the void is not only a physical mystery, but a metaphorical one. Heidegger spoke of das Nichts, the nothing, as a confrontation with the edges of human existence. Camus saw in the silence of the universe a challenge to live authentically, to embrace life despite its indifference. Modern thinkers continue this dialogue, weaving scientific discoveries into timeless debates. Every new discovery about dark energy or vacuum energy deepens the philosophical riddle, as if nature itself were forcing us to reconsider what it means to exist. This union of science and philosophy is not a contradiction but a necessity. When astronomers measure the cosmic microwave background, they map not only radiation but also humanity's attempt to understand its beginning. And case, when particle physicists search for symmetry and order in the quantum realm, they are echoing questions once posed in temples and forums thousands of years ago. Both disciplines arise from the same spark, the refusal to accept ignorance, the insistence that emptiness must hold a story. What is striking is how the void transforms our sense of scale. Science reveals that nothingness is not empty but structured, a fabric woven with invisible forces and hidden energies. Philosophy, in turn, reminds us that even if we could describe that fabric perfectly, we would still face the unanswerable. Why is there something rather than nothing? Between the two lies the human experience, caught between measurement and wonder. Perhaps this is the true gift of the cosmic void. It refuses to be tamed by a single perspective. To the scientist, it is a puzzle of particles and energy fields. To the philosopher, it is a mirror reflecting our deepest anxieties and hopes. To humanity as a whole, it is both an endless silence and an invitation to speak. The void forces us to stretch not only our instruments but also our imagination, challenging us to construct meaning in the face of infinite absence. In this dialogue between science and philosophy, the void emerges as a partner rather than an enemy. It does not close the story of existence, it opens it wider. In the silent spaces between galaxies, in the dark matter that shapes the cosmos, in the vacuum energy that fuels expansion, lies a profound reminder: the universe is not finished, neither are we. The human response to infinite emptiness, standing beneath a night sky scattered with countless stars, humanity has always felt a dual pull, awe at the majesty of creation and unease at the silence between those points of light. As science has sharpened our vision, expanding our reach beyond planets and galaxies into the endless darkness, this unease has deepened into a profound confrontation. How do we, fragile beings bound to a single world, respond to the immensity of nothingness that stretches in every direction? For ancient cultures, the void was rarely described as absence. It was instead personified as gods of darkness, oceans of chaos, or wombs of creation. The Egyptians spoke of Nun, the primordial waters from which all life emerged. The Greeks told stories of chaos, a yawning gap that gave birth to the cosmos. In these mythologies, emptiness was not sterile, it was fertile, brimming with unseen potential. The human response was to weave stories, to transform fear into meaning. In the modern era, the telescope replaced myth as our guide, yet the same confrontation remained. The more we discovered, the more the silence seemed overwhelming. Astronomer Carl Sagan described the Earth as a pale blue dot suspended in a sunbeam, a reminder that we are tiny within the void. For many, this realization evokes humility, even despair. If the universe is so vast and we are so small, can our lives matter at all? But there is another response, one rooted in resilience. Instead of shrinking before the void, some thinkers argue that it gives our choices more weight. In an infinite silence, it is our voices that create meaning. Existentialist philosophers such as Sartre and Camus insisted that the absence of preordained purpose liberates us. The void does not dictate, it invites. We are free to inscribe our own narratives against its dark canvas. Psychology too has expert, or the human reaction to cosmic emptiness. Studies show that confronting the vastness of space often triggers what researchers call the overview effect. Astronauts who have seen Earth from orbit frequently report a transformative shift in perspective, an overwhelming sense of unity and connection, born not despite the void but because of it. Looking into nothingness, they discover the preciousness of something, life, fragile and luminous against the dark. Religion continues to offer another response. For many, the void is not the absence of meaning, but a reminder of mystery, a space where divine presence is felt precisely through silence. In prayers spoken under starry skies or rituals marking the rhythm of celestial bodies, the infinite becomes not alien but intimate. Whether through faith, philosophy, or science, humans refuse to accept emptiness as final. We fill it with stories, equations, prayers, and dreams. What unites all these responses is a refusal to let the void remain silent. Even when it confronts us with insignificance, we answer with creativity. We launch spacecraft into its depths, carry radio signals across its vastness, and etch golden records filled with our voices and music, hoping someday they will be heard. The void may appear indifferent, but humanity insists on dialogue. This persistence is not merely survival, it is defiance. In the face of infinite emptiness, we choose to create, to imagine, to explore, to love. Perhaps that is our greatest triumph. The void may dwarf us, but it cannot erase us. Instead, it magnifies our determination to matter, no matter how small our place may seem. In this way, the human response to nothingness is itself a paradox. We face silence with song, absence with presence, and emptiness with meaning. The cosmic void does not diminish us, it defines us. The final threshold of knowledge at the farthest edges of human exploration, both in the physical universe and in the abstract terrain of thought, lies a threshold that feels almost insurmountable. It is the point where observation reaches its limit, where technology can no longer probe deeper, and where the intellect begins to fold in upon itself in recognition of its own constraints. This threshold is not simply a boundary of science. It is a philosophical horizon that forces us to confront what it truly means to know anything at all. In cosmology, the limit is the cosmic horizon, the farthest distance from which light has had time to reach us since the birth of the universe. Beyond it, there may exist uncountable galaxies, structures, or even entire domains of physics unlike anything we can imagine, yet they remain invisible, unreachable, and perhaps forever unknowable. In philosophy, a similar horizon exists, the realization that consciousness itself is bounded, that our grasp of reality is framed by the very structure of the mind trying to perceive it. For centuries, thinkers have asked whether the human mind is equipped to comprehend the totality of existence. The void magnifies this question to its highest intensity. If space beyond our sight is infinite, if its depths are filled with dimensions we cannot measure or forces we cannot detect, then perhaps our universe is larger, stranger, and more unknowable than even our most daring theories suggest. To stand at this threshold is to gaze into a domain where human knowledge may never penetrate, where nothingness is not merely absence but a veil concealing what might never be revealed. Yet, within this humbling recognition lies an odd kind of freedom. If knowledge cannot be absolute, then exploration becomes not about final answers but about the journey itself, the attempt to push deeper, to uncover fragments of truth to create meaning in the act of reaching. Science does not end at the threshold, rather, it thrives in brushing against it, in admitting its limitations while still daring to imagine what lies beyond. The final threshold of knowledge is not a wall to be broken, but a mirror reflecting back our desire for discovery. It teaches us that perhaps the greatest wisdom lies not in conquering the void, but in learning to dwell within it, to accept that the pursuit of understanding, even when incomplete, is itself a cosmic act of significance. Dwelling in the silence of the void, as our journey through the cosmic void draws to its conclusion, we find ourselves not at the end of knowledge, but at the beginning of a deeper awareness. We set out searching for the meaning of nothingness, expecting perhaps to find emptiness, lifelessness, or absence. Instead, the void revealed itself as a paradoxical presence, an arena where silence holds potential, where absence becomes a canvas for possibility, and where stillness echoes louder than any noise. The void is not just an astronomical reality, but a philosophical invitation. It calls us to consider how fragile, how precious, and how improbable our existence truly is. The infinite silence surrounding us is not indifferent. It is the stage upon which the drama of galaxies, stars, and life itself plays out. The nothingness is not hostile. It simply is, vast and unyielding, a reminder that life's beauty shines brightest when contrasted against immeasurable darkness. To dwell in the silence of the void is to accept humility. It is to recognize that human ambition, achievement, and even understanding exist within a fleeting instant of cosmic time. Yet within that instant, meaning flourishes. By contemplating nothingness, we sharpen our awareness of being. By facing emptiness, we deepen our gratitude for presence. By imagining the infinite, we learn to cherish the finite. This acceptance does not end in despair. It opens a new perspective. If the universe is vast beyond comprehension, then our smallness is not a weakness, but a gift. It means every choice, every act of kindness, every moment of awareness carries profound weight precisely because it is fragile against the endless silence. As explorers of thought and dreamers of stars, we may never fully pierce the veil of the void. Yet we can learn to live within it, not as conquerors, but as participants in its unfolding mystery. The cosmic silence does not demand answers. It invites us to keep asking questions, to continue wandering, and to embrace the unknown as part of our shared destiny. And so, as we step back from the edge of nothingness, we do not leave it behind. The void remains with us, in every breath, every thought, every act of wonder. It is not a place we travel through, but a truth we live within. To dwell in its silence is to stand in awe, to recognize that even amidst infinite nothingness, we have found something extraordinary, the miracle of awareness.